மேடம் ஆஃப் ஆகிடும் உங்களுக்கு பிடிக்காது
ஆஃப் ஆகுது சார். ஆஃப் ஆனாலும் அது இருக்கு. ஸ்டார்ட் பண்ணிடலாமா? லைவ் போயிட்டு இருக்காங்க. ஓகே, லெட்ஸ் ஸ்டார்ட். நோ.
Hi students, welcome to Future Dr. NEET Academy for the problem solving session in NEET Physics. Topic chosen today is from chapter 4, Laws of Motion. Already we have floated the questions, 7 questions in the previous session. Now we will solve the solution for these questions. Let's move to first question. A ball of mass 0.15 kilogram is dropped from a height 10 meter, strikes the ground and rebounds to the same height. The magnitude of impulse imparted to the ball is nearly dash. Given g equal to 10 meter per second square. Yes, option B, 4.2 kilogram meter per second is the correct answer. Formula is impulse equal to change in momentum, that is dp, and dp is nothing but m into delta v, that is nothing but m into v2 minus m into v1. And from equation of motion, third equation of motion, that is v square equal to u square plus 2as. From that u equal to 0 and v, final velocity v equal to v1, a equal to g, because ball is dropped from a height. So acceleration is equal to acceleration due to gravity plus g, and s is height h. Then from this v1 equal to square root of 2 into g is given 10. 10 into h. What's the value of h? H also 10. And 10 into 10, 100, that square root is 10. Therefore, v1 equal to root 2 10 or 10 root 2. Better to write 10 root 2. 10 root 2 meter per second. And when it is rebounds to the same height means v2. v2 equal to minus 10 root 2 meter per second. That you want to substitute here. I equal to m, common take out. M into m is 0.15. 0.15, that is m, into v2 minus v1, that is 10 root 2 minus of minus plus 10 root 2, that is 20 root 2. 0.15 into 20 root 2. 15 into 2, 30. 15 into 2, 30, and 0.15 into 2 means 3 into root 2. What's the value of root 2? 1.414. 1.414. If you simplify this, you will get 4.2 unit kilogram meter by second. This is the value of impulse I. Option B. Option B is the correct answer. Let's move to question number 2. A man of 50 kilogram mass is standing in a gravity-free space at a height of 10 meter above the floor. He throws a stone of 0.5 kilogram mass downwards with a speed 2 meter per second. When the stone reaches the floor, the distance of the man above the floor will be dash. That is m1 r1 equal to m2 r2, or mr is constant. Mr equal to constant. And from this find r1, and m1 is 50 and r1 you want to find. R1 equal to m2 r2 divided by m1 equal to m2 is 0.5. into R2 is 10 meter divided by M1. M1 is 50. Then it gives 10 into 0.5 is 5. 5 by 50, that is 10, 0.1 meter. Question is, distance of the man above the floor will be. So 10 plus 0.1, that is only distance of the man above the floor. S equal to, or H equal to 10 plus 0.1 equal to 10.1 meter. Okay, option B. Option B is the correct answer. Let's move to question number 3. A player takes 0.1 second in catching a ball of mass 150 gram moving with velocity of 20 meter per second. The force imparted by the ball on the hands of the player is, that is from Newton's second law only. Force acting is nothing but rate of change of momentum, F equal to m into V1 minus V2, and V1 is 20 and V2 is 0. 20 meter per second and V2 is 0. And time is given 0.1 second. 0.1 second. Substitute this here. Then F equal to, M also given, no, 150 gram. M equal to 150 gram, convert into kilogram into 10 power minus 3 kilogram. Substitute F equal to 150 into 10 power minus 3 into V1 minus V2, that is 20 minus 0, divided by T 0.1, that is F equal to 150 into 10 power minus 3, 0.15 by 0.1 multiply and divided by 10. Or 20 is there, no, into 20 is there. Wait, 20 we missed. Into F equal to 150 into this 0.15 into 20 by 0.1 into 10 by 10 equal to 30 Newton. That is option C. Option C is the correct answer. Let's move to question number 4. The force on a rocket moving with a velocity 300 meter per second is 210 Newton. The rate of consumption of fuel of rocket is dash. This is also same Newton's second law of motion only. F equal to d by dt of m into v. And here velocity is constant, there we have change in the mass. That is F equal to v into dm by dt. From that you want to find rate of consumption of fuel, that is dm by dt equal to, what's the formula? F into F by V. What's the value of F? 210 Newton. Value of V is 300 meter per second. 300. This 0 getting cancelled. Then 21 by 30, that is 3721 and 310 30. 7 by 10. 7 by 10, that is equal to 0.7 unit kilogram by second. That is rate of consumption, change in mass with respect to time. Option A. Let's move to fifth question. A 10 Newton force is applied on your body produces an acceleration of 1 meter per second square. The mass of the body is. This is also same Newton's formula, second law of motion, F equal to m into A. What is the given data? Force is given, that is 10 Newton. Then what is the other thing given? Acceleration. A 600 kilogram rocket is set for a vertical firing. If the exhaust speed is 1000 meter per second, the mass of the gas ejected per second to supply the thrust needed to overcome the weight of rocket is dash. This is also same Newton's second law, and here velocity maintained constant. So F equal to V into dm by dt, and here mass of the gas ejected per second, that is dm by dt only. Dm by dt equal to F by V, and instead of F given is given 600 kilogram. F equal to m into G, and m is 600. 600 into G 10. Assume G as 10 meter per second square. Then that is F equal to 600 into 10 divided by velocity V. How much? 1000. 1000 is given. Then these 2 0 getting cancelled, this 0 getting cancelled. Then this is equal to 6 kilogram per second. That is option C. Option C is the correct answer. Let's move to last question. A man weighs 80 kilogram. He stands on a weighing scale in a lift which is moving upwards with a uniform acceleration of 5 meter per second square. What would be the reading on this scale? That is free body problem we want to apply. R minus mg equal to m into a. If it is moving upwards, R minus mg. Moving downwards, mg minus r. That is the only difference. And m is given 80 kilogram. And what's the other thing given? Acceleration given. Acceleration a equal to 5 meter per second square. 5 meter per second square. Then substitute, and you want to find the what would be the reading on this scale. That is the apparent weight. Or only you want to find. R minus mg equal to ma. R equal to mg plus ma. And R equal to m into g plus a equal to m 80 into g is given 10 meter per second square. So 10 plus 5. 10 plus 5 is 15. R equal to 80 into 15. 80 into 15 coming 1200 Newton. That is option B. Option B is the correct answer. Okay, thank you students. So in next session we will see it through other chapter. Okay, thank you.